Hi there, algebra students. Today we're looking at lesson 10.5, factoring perfect squares. Again, this is just a variation of a lot of the other factoring we have done with just a few little idiosyncrasies, as we'll see. So today our focus is on perfect square trinomials, and here are the formulas for those. Again, we've seen these last chapter again when we were multiplying them. So last chapter we went from this to this, and again it's really just a glorified example of the FOIL method when we were multiplying them. But again, keep in mind in this chapter we'll be starting with the polynomial, and then we'll be breaking it down into what we call factored form. But again, here's a nice diagram of a algebra tile-ish type figure that you can see how this perfect square trinomial fits in. Alright, here's some examples that we'll take a look at, and I'll just do some of these as we go along here. So again, remember the first thing we always look for when we factor is common factors, and on this particular one there are none for all three parts of that trinomial anyway. So then we would make our two sets of parentheses like this, probably going to be x and x. And then we do have some different combinations that would get us to 36. Chances are, though, that since this is in the lesson of perfect squares, that both of these are going to be the same. So it is 6 times 6. And here's my cat Puma again helping me. There she goes. So 6 and 6, but then the question would be what kind of signage goes in the middle. And again, you have to notice that since that middle term is negative, that's what my signs have to be in each of these. So x minus 6 times x minus 6, or of course you could write that as x minus 6 squared like that. Okay? Alright, next example. A little bit trickier. Now, here's kind of a clue here. When you see that that last number there is negative, that might raise some red flags. Because in order to get a negative number, you have to have a positive times a negative. Hence, it would not be a perfect square. But let's take a look. There's no common factors here. Looks like it would be a and a. And one would think that there's 49 and 14. It seems like 7 and 7 would be a good match. But again, if we put plus signs in here, which would give us that 14a in the middle, then I'm not going to get a minus 49. So this is a case right here where we can't factor this one, and really that is considered to be a prime polynomial. That's not going to happen too often, but in this case it does. Alright, let's take a look at one other last example down here then. This one's a little bit more messy because we've got extra variables in there. I don't really see any common factors. Again, there are some in 2 of the 3 terms, but not in all 3. So then we're going to make our sets of parentheses like this. And it's kind of nice on these perfect square ones, we're looking for square roots. So it looks like it would be 7m. In this case, 7m times 7m is 49m squared. And of course, the square root of 9 is 3, and it's going to be 3n. And what kind of signage do you think it'll be? Well, again, if you just focus in on that middle term here, since that's negative, chances are that's what this is going to be too. Because a negative times a negative gives you a positive for our last value. And when I look at my innards and my outards, sure enough, that gives me that middle term that I'm looking for there. All right? So, that's the deal there. Next slide. Here's kind of a different one. Determine all values of k that make the trinomial a perfect square. So we're trying to figure out what k is going to be in this case. So I'm going to just start out like I normally would. And if it's a perfect square, they have to be the same. So 3x and 3x. And of course, the only way to get 16 with both numbers being the same there is going to be 4 and 4. It's going to be plus like that because my sign of my middle term is positive. Now let's multiply this out. see what that k value would be. Again, we're mainly interested in those innards and outards here. So 4 times 3x is 12x. Same thing on the other side. So it looks like that middle term there would have to be 12 and 12, which is 24x. So if you're thinking about k, and here's where it's just slightly tricky, we would think that k could be only positive 24 because we see that positive sign there. However, if k were negative 24, I think that would still work. It's just that there would be a negative sign in there, or our k value would be negative 24, so we could have plus and negative. So I think it could be negative as well. Sometimes when both positives and negatives work, we say plus or minus 24, like that. We've seen that maybe a couple other times so far in this class. All right, to finish thing off, here we have a perfect square watermelon, it looks like, to help remind you of these perfect square factoring. I think this guy actually made this by growing a watermelon in a square container. Hard to believe. Anyway, thanks for watching, everybody, and we'll practice on these in class tomorrow. Bye now.